Welcome again to COM 223. Okay. I remember we stopped somewhere here in the previous study. We stopped here this week one, talking about resistors, color coding. Here we are going to demand you to know how to get the value of a resistor. The value of a resistor by the color. So I believe we touched this, and if you look at it once again, you will understand. So this color coding in resistor, I will require you to tell me the value of a resistor when you are given the color code. Give us the value and the tolerance and all that. So let's go to page 21 and talk more about resistor also. Okay. The basic principle of semiconductors. Okay. Actually, here we are talking about resistors. Still resistors. We have a type called fixed resistor. There are some resistors that are variable resistors. Right? Now, this is a diagram of a resistor, and if you read the text, it said during manufacture, a thin film of carbon is deposited onto a small ceramic. Okay, look at the picture. A thin film of carbon deposited on a small ceramic rod. Okay, it's like a coating. The machine coats the ceramic. Carbon has resistance, so the length will determine the resistance. The longer the length, the higher the resistance. So it is turned round about the ceramic. If you want a resistance that is high, you keep on turning. You keep on turning. Tiny turns. Okay? If you want a little value of resistance, you turn it just a little. So that is how the resistance of a resistor is determined at manufacturing state. Now, let's talk about, there are resistors that are made of carbon film, and there are those that are made of metal film. Okay, metal oxide. So for carbon film, it is easily made, it is cheap, but the value has error of maybe plus or minus 10% or 5%. So the error there is much. Remember, it's cheap. The metal film is different. It is not easily made, but the error there is little, plus or minus 2% or plus or minus 1% of the nominal value. So and that is what we saw in the color code. If you go back to the color code, you discover that there are bars at the terminal end, the other end, tolerance. So when a resistor is labeled 10 ohms, you look at the tolerance. The tolerance can tell you, well, it is 5% or plus or minus 5% wrong. That means there will be slight error, plus or minus 10%. So you look for 10% of 10 ohms. 10% of 10 ohms. So you deduct it, or you add it to the 10 ohms. Okay, I believe if you read through in the previous lesson, you read through, you'll get it. So for carbon film, the error is greater, but it's cheaper. For metal film, the error is smaller, but it is more expensive. Now we have wire wound resistor. They are made by winding thin wire onto a ceramic rod. Okay. And that can be extremely accurate. Remember, the higher the accuracy, the more expensive it may be. Now, the function of resistors. Like I said, resistor limits current. Look at this diagram. That's what we call LED, light emitting diode. It needs a current to pass through with a certain fixed amount of voltage that will be dropped there. The current will pass through and it will glow. But if you just connect it to 9 volt, as you can see, the 9 volt may be too much for it. And the 9 volt being higher, the higher the voltage, the greater the current. You remember Ohm's law? The higher the voltage, the higher the current that will flow. So you have to drop the voltage and resist the current using what? Resistor. Like this LED requires between 10 milliampere to 30 milliampere. So if you don't use a resistor, you might be passing through it 100 milliampere. That will burn the LED. So the function of a resistor is to resist or limit current. I know we have mentioned this before, but just to talk about it again. Then we talk about the symbols of resistor. In Europe, they use this box-like symbol. In US and Japan, we use this zigzag-like symbol. But all the same, resistor is resistor. Anyway, so whatever diagram you see or symbol you see, you should know it's resistor. Now, resistors are used with transducers to make sensor subsystems. What are transducers? Transducers are electronic components which convert energy from one into another. One of them is electrical. One of the energies electrical. Okay, you can be converting light energy to electrical energy, as we see in light dependable resistor. This light dependable resistor, when you bring light energy into it, then it electrically affects some things. Okay, and that is an input transducer. Input transducer. That means the energy coming in is different from electrical energy. Okay. Now, let's go to another one. Another one is a microphone. Microphone will convert sound energy to electrical energy. Input transducer. There's something else at the input other than electrical. Now, talking about output transducers, that means they output another energy from electrical energy. That means electrical energy comes into it and it is transformed to another energy, like we have in loudspeaker. Electrical energy flows through the coil and it produces sound. That's output transducers. Then filaments of the lamp and of LED, they also output transducers because they use electricity to produce light. There are many things you can think about. Think about transducers. Think about the types of transducers. And you should be able to explain to me all that we have said now. We talk about types of resistor. And we are talking about transducers too. And their types. What is a resistor? What are their types? What is a transistor? Transducer. What are their types? Now, they are repeated here. Carbon film, wire wound, axial lead, and all that. Okay, then they are taking us back to color code. This color code is very important. You go to buy resistor. They give me 10 ohms. They give you 1000 ohms. If you don't know it, you buy anyhow. So you need to know. Once again, you need to know, especially those of us that are in engineering. You need to know. You need to know, okay, the first color, what is the value? Maybe the first color is yellow. So you go to yellow, that's 4, okay? Second color is what do we call that? Purple. Purple. Okay, violet, violet. That's 7. That's 47. But that's not the end. The third color, is that not orange? Yes. So the third color is 40. The value of that resistor is 47 times 10 raised to power orange. Okay? It's funny. For you to understand, 47 times 10 raised to power 3. Orange is 3. The first color is 4. Second color is 7. The third color is 3. 47 times 10 raised to power 3. That third band is a multiplier. The first band is the first digit. Second band, second digit. Then third band, multiplier. Then the next one is tolerance. Tolerance is silver or gray. And that's 8. Am I saying right? Yeah, that's 8. Okay, see it here. 47 times 10 raised to power 3 means 47 kilo ohms. Alright? So, tolerance. Tolerance, I'm saying silver. Silver is, okay, gray. Is there anything like silver here? Okay, I'm saying tolerance 2% is red. 5% is gold. Okay, 10% silver. Okay. This 8%. 8%. Alright. So that's that. Introductory information. Being able to determine the polarity cathode versus anode of a diode is very important skill. Okay. Now we are learning how to test for this semiconductor called diode. Semiconductors. These are special materials in engineering, in physics, and these are the things that have made technology to evolve. The discovery of semiconductors. Semiconductors is like they are not actually conductors. Before they conduct, there will be a condition before they conduct. That's why they call it semiconductor. Because you can come to it, it does not conduct for you. But another instance, it will conduct. They call it semiconductors. Call them semiconductors. Like diode, it will not conduct if the voltage is lower than 0.7 volts. It will not conduct. To block it, current will not pass until the voltage is up to 0.7 volts. It will not pass. And it will drop 0.7 volts. The excess over 0.7 volts will be passed on. Okay? Semiconductors. You need to know how to test for them. The anode is the positive side That is where current comes in through anode. Anode is a receiver. Cathode is a giver. So current comes in through the anode and passes out through the cathode. So when you connect your diode to a tester, a multimeter, it should give you a reading. The reading is either infinity, that means nothing is passing, or it gives you what? Gives you 0. Say there is no resistance. It acts as if there is no resistance, or the resistance will be very slow, very low. Now, if it shows you infinity, that means you have turned it upside down, like the one you see on the right. If you put cathode to positive, anode to negative, it will not happen. You see, diode will also not conduct when you reverse it. It is polarized. That means there is an input, there is an output gate. You cannot just use it anyhow. Diode is like that. There is where current should pass through to enter, and that's the anode. And if it is up to 0.7 volt, it will pass. If you reverse it, even if it is more than 0.7 volt, it will not pass. That's why I call it semiconductor. It will conduct at some certain conditions. So when the current is flowing, as you connect it correctly, the current will flow. You see the resistance very low or 0. But if you reverse it, current is not flowing, so it will act as if there is space in between the multimeter probes. That means current cannot flow. There is something that must be in between the probes for current to flow, and that means there is nothing in between because they are blocked. They are blocked. Now that's about semiconductors. Now we have types of meters. We have analog meters. Okay, this is still digital. But we have analog. We have digital. So many people are used to digital now, but as a science student, as an engineer, as a computer scientist, you need to know how to use analog, and that is practical anyway. So each and every one of you should have a multimeter. Start with analog. So bring the analog multimeter to school. You should have it. We'll show you how to use it. Okay? When the other engineer brings his own too, we now use them together. Okay? For digital, I will not mind if you have digital or not, because you can always have it and use it. It's easy. It's analog that is more difficult, which you have to learn specially. Okay, diodes have different types. All these that you see, they are diodes. You have black color diode. We have a diode in this one that looks like transistor diode. Some are Zener diodes. Zener diodes are special diodes that even the reverse can still allow current to pass. Well, let's leave that for another day, that you don't forget all those vital things that we need, because you are just computer scientists. You may not need to know all of them at the same time. Now, I was sorry for that. Something is going on here. Did I lose it? Okay, I get it back. So, transistor testing. Okay, how do you test for transistors? Just like you test for diode, but it's more than that. We are going now. Okay, this is it. Collector to base, then emitter to base for PNP transistor. That's how to test for it. There must be a reading, not infinity, not error. Okay, you want to discover the base. You go through all this. Okay. I'm taking us to where we have our business. Okay, all these are good, but it looks as if you are borrowing courses. This is still about color code, I think. Still about color code for resistors. Okay. Understanding the importance of preventive maintenance of hardware components. Look at it. Look at it very well. Maintenance of the case. They use a clean cloth, light damp with ammonia cleaner to remove dust, dirt, and stains from the exterior of the PC. Yes. You clean it up. You can read more about that. You can pause the video and read. The next thing, maintenance of the air intake. Maintenance of the air intake. The air intake is there at the back of the PC. Even a laptop has that. You have to clean it. Yes. You have to pay attention to that. Check for accumulation of dust and debris so that you remove it. There's a filter there, yes, but the filter can be blocked also. So clean all the dirt and accumulations, remove so that air can easily go into it. There are some filters that are washable. Then remove it and wash simply with soap and water. Alright, maintenance of speakers. All these that we are mentioning have to be dusted. You remove the dust. Now, speaker has nets or some kind of clothing or filters where dust can easily hide. You have to remove it. Then the cone of a speaker can be dusty. You clean it gently. Can use ammonia solution. Clean it gently so that you don't perforate the cone. Because when the cone is perforated, the speaker will not do well anymore. Okay? Understanding preventive maintenance of hardware components. Internal cable checking. Maintenance. Why is my system not booting? Why is it not working? I want to check inside. I want to check the power cables. Maybe you start from outside. If the power cable is bad, replace it. If the power cables are okay, then you have to open it. Check the PC, the system unit. Check for the motherboard components, the connectors. All those four pin drive power cables. Those set of power cables from the power pack. Check for them. Are they connected? Floppy drive ribbon, the data cable for the floppy drive, hard drive, CD-ROM. You check. Are they in order? Okay, are they broken? Replace. the one that is working, bring it to the one that is not working to check whether the ribbon is the problem. That's how to troubleshoot. Then there are some cables, LED cables. You check. On and off switch cable. Check. There's this audio wire for the CD-ROM. It connects to the sound card. Check. SCSI ribbon cable. If you are using it, check it. And these other ones. Then memory checking. I want to check. There are SIMs, there are DIMMs. Single inline memory modules. Then we have dual inline memory modules. And some computers have the two, some have one. That is where the RAM is situated. The RAM is planted into the SIMs or the DIMMs. You want to check whether the RAM is faulty. Although there are some cases the fault from RAM will make a particular sound. We did that in the other year, some semesters back. There's many signals, symbols, symptoms, sounds, beepings that have different meaning interpretations. So you can check the RAM. Is it well planted? When you are planting the RAM, you should hear a clicking sound. And check the CPU. That's the single largest IC in the motherboard. CPU, you can remove it carefully. Check it. Is the fan rolling there? If the fan of the CPU is not working, then there may be a problem with that CPU. Because the moment the fan ceases, that thing may be hot and spoil. So you find an heat sink on it. Then you find the fan. So you can remove the CPU, the microcontroller, the CPU. Remove it. Be careful when you are putting it back. You need just 0 insertion force. You don't press it. You don't need clicking sound. When you drop it, it goes in by itself without any force. 0 force. So you can examine it. Replace it to check. Probably that's the problem. All that. You can read more. Check drive mounting. Each drive should be mounted properly. Then update the boot disk. Your PC should always have a boot disk. We can start the system from a floppy drive. In the event of emergency, like Windows 95, has the ability to create startup disk automatically. If you have access to Windows 95 system, use the following procedure to create a startup disk. See the procedure there? So I can ask you to give me all these maintenance procedures, maintenance and troubleshooting. I can ask you to also tell me how to create a startup disk in Windows 95. You label the blank diskette, click on Start, Setting and Control Panel, double click, Add, Remove, select the startup, click on Create Disk, use the utility to remind you to insert and all that. You can also maintain system by running ScanDisk. This one will scan the system to discover where there is a problem. Wrong disk frag. This one tries to rearrange the data in your hard disk. Maybe they are scattered and waste spaces. Arranges them more orderly. Preventive maintenance troubleshooting. Okay. one is preventing problem from happening. Now let's talk about the diagnostic techniques in corrective maintenance. Installation of graphic cards. Okay, this practical, we have to open it and do all the stuffs here. Okay, see the picture. There's something we call expansion slot. That's the expansion slot cover removed. Then I think they are planting expansion card here. Okay, the card is being planted, and at the back of the system there's a new, a new port from the card. Let me see the power pack being plugged. Okay. If you want to troubleshoot your monitor, that's it. And go through it. Now we see memory failure symptoms and troubleshooting here. If the memory fails, what do? Number one, it is caused by this set of activities. When you use a wrong type of memory failure can occur. And you did not install correctly, you don't configure correctly, when you put the modules in the wrong socket, when you forget to change jumpers that may be present, when you are using unsupported technology, unsupported module sizes, when hardware failure of the memory itself takes place, what do you do to remedial the problem? Remedial procedure now: check for possible general problem associated with new systems. Make sure to carefully check the memory modules. Check for loose connections within the PC. All that. Just read through. Now, installation of keyboard and pointing devices. I should be asking you to do this. Maybe I've taught you before. Installation of keyboard and mouse or other pointing devices at some different types of keyboards. 101 key enhanced keyboard, 104, 82 and 108 key enhanced Apple extended keyboard. There are various forms. Look at this one, normal Windows compatible keyboard. Look at this other one, multimedia keyboard. This one you can play. Look at the side. Look at this side now. You can play, press play, press stop and all that. This kind of keyboard, just plug it, press play. The computer will locate wherever the music is kept in the system and you start playing it. So we have normal computer keyboard and multimedia keyboard and ergonomic keyboard. This one is made in such a way that you will be well comfortable. You will not be tired, you will not be stressed. We have cordless keyboard. These are keyboards. I think I have one here. It uses Bluetooth. No cord. Even the mouse, no cord. Then we have projection keyboard. These are the latest types of keyboards. You see that camera? That projector. It has a projector and a sensor. So you project something and looks out for your finger as your finger blocks some things, it will interpret it to the keys, to the letters, the numbers. How do you troubleshoot that? Read it up. Read. Know how to troubleshoot. Okay. See, power down the system. Number one, identify the types of keyboard. Is it PS2 or USB? If it is PS2 that you are using and it's not working, you shut down. PS2 will not allow you to use keyboard when you plug it while the system is on. You must plug it before starting the system if you want it to work. On the other hand, the USB keyboard, just plug it anytime, whether the system is on or not. It will embrace it, to welcome it, to start working. Okay, keyboard cleaning. Yes, blowing it or using a kind of brush. You can follow the way to do it there. Okay, installation of dial-up modem. Modem are modulators, demodulators. You want to install it, you have to shut down and bring it into the expansion slot. Okay, especially one that is far away from other components. So you remove the cover on the casing, you bring the board inside, the card. They call these things that you plant into the extension port, they call them cards. So plug it in. Okay, the modem card is plugged in, and at the end, at the back, you plug in your modem cable, like our J45 cable, telephone cable. You have to screw it, secure the card by screwing it into place and connect. That's it. All right, there are more to read there. Read up. Modem. It may interest you, so read it up. Okay, I think finally we have printers. System installation procedures. Printers. You want to install printer, local printer, network printers. Okay, you can install. Number one, you plug in the cables. Then the software of the printers has to be installed. The software has to be installed in the computer. The procedures are here. When you have installed them, make connection with a port, printer port or USB for this generation. Then you have your printer working fine. You're ready to print and ready to enjoy your computers. Okay, I would like to stop here. Okay, read it up. I will set exam based on what I've taught you. Although I may not explain everything, but I expect you to read deep and you give me answers. Give me good answers and you're okay. All right. Have a nice day.